Hello and welcome everyone to another episode of Altitude. I, of course, am Woody Woodworth. Very cool show today. I'm super excited. We are going to have another follow-up conversation about containers and Kubernetes with the fabulous Mitch Connors, who joins us today now as the head of product and strategy for platform engineering at Aviatrix. Welcome, Mitch.
Hey, thanks for having me, Woody. How you doing?
Doing great. Thanks for coming back on the show. Very excited about your new role and very excited about maybe having a sneak peek at what's going to be happening with Aviatrix and Kubernetes in the near future. We had such a good first interview and a lot of people really liked that show. I wanted just to get you back on the show to talk a little bit more about Kubernetes and containers, but this time at an industry level. So maybe the first thing we could do is just let myself and listeners know, what's going on with Kubernetes today? What are the hot topics out in the news?
As you mentioned, I've transitioned to a product management role inside of Aviatrix. It's the first time I've ever done something like this. I have no idea what I'm doing. I've been a developer for 19 years, and now I've been a product manager for 4 months. But part of being a product manager is market research and understanding what's going on in the market. And I've learned a lot in these 4 months. It feels like Kubernetes has exploded. If you attend events like KubeCon, everybody's using it, and it gets to be hard to imagine that there's any applications left in the world that are not running Kubernetes. And yet, when you zoom out just a little bit and get a wider industry perspective, the migration to cloud, remember that started like back in 2008. So you'd think 16 years later, we're definitely done by now. We're halfway done. Half of all enterprises have migrated onto the cloud. This is actually the first year that public cloud spending will match data center spending. 2024 is the first time that's ever happened.
Interesting. I didn't know that. That's a great data point.
The trend for Kubernetes is, I think, the same. It feels huge if you're present. If you're operating in cloud, it's hard to believe that there's still half of the world not running on cloud. But when we zoom out, we see that Kubernetes is actually still in its infancy in terms of adoption. Somewhere between 5 and 15% of all enterprise applications run on Kubernetes today, which is a big chunk. It's huge progress for Kubernetes. It's amazing adoption, but it also means there's still 85% left that have not. Now, some of those 85% will never get there. Others are going to happen within the next 5 or maybe 8 years. But we're even still, not just there's still adoption to be done, adoption is still accelerating for Kubernetes. It's getting faster and faster. It's hard to believe after how fast it felt last year that things could be faster still. And yet that's absolutely what we're seeing in the industry. And that adoption is being driven now primarily by enterprises. And enterprises have to approach Kubernetes in a very particular way. It's very much like adopting cloud. So when I first did a cloud migration, I was at a small startup and migrating from our one rack data center, it was in a closet in the office, to the cloud took about 2 days. We had to figure out what this VPC thing was. We had to figure out how to spin up VMs. We had been running on, I think, Zen for virtualization in the data center there. But we got all those things hammered out. We figured it out. We migrated it. We had a couple hours downtime, but we're a small startup, so it didn't matter. And then everything's running the way that we wanted it to. That doesn't scale to a 50,000 person enterprise running thousands or tens of thousands of racks in a data center.
Right.
That process is really, really difficult. It requires all kinds of planning and tooling. And actually, that's been one of the sweet spots for Aviatrix, is helping out with that initial cloud migration for network engineers, helping them wrap their heads around what the changes they're going to experience are. I think Kubernetes is the exact same thing. And so you're seeing a field called platform engineering really spring to life in the enterprise world for Kubernetes adoption. The idea here is your developers shouldn't necessarily need to think about Kubernetes. They shouldn't need to think about a service mesh or a CNI, or whether you're using the gateway API or ingress or the other 1,000 choices you have to make in your Kubernetes adoption journey. They should be pretty agnostic to that. Instead, they get a very limited surface area where they're able to say, hey, here's my container. Maybe here, there's 5 patterns of how to run it. We can run it high availability, regionally scaled for low latency. We could run it just in one data center or one region to save money on compute. So I pick from one of those templates and I click go. That's the end of my involvement as a developer, because I'm just integrated with the internal developer platform, which is a product that platform engineering team produces. The platform engineering team are the experts. They're the ones who have to dig deep and understand all the details of all the technology instead of having your whole software org understand it.
That sounds fantastic. It also sounds like it'll be a journey or a marathon, not a sprint. But of course, I've always thought about those kinds of platform approaches and then said, but what about the network? Because a lot of them are top heavy, meaning they tilt in towards application elegance and workload business elegance. But the infrastructure pieces sometimes are an afterthought or missing. So in this new world of platform engineering, where does the network fit in? And will there be some tools or approaches that you think will benefit traditional networking teams? Because Kubernetes and traditional networking have always been a little at odds with each other.
They really have. The platform teams really vary depending on the size of the company. But no matter where you go, no matter how big the team is or how small the team is, if you ask them, they're too small. So many times at KubeCon in Chicago, I talked to someone who told me, yeah, I'm a platform engineer on a 5-person team, and we serve a 4,000-person software engineering org. So that company has devoted less than 0.1% of their engineering resources to building out the platform that everything will run on. That's a little bit scary, but it's also a testament to what is possible with these new technologies. So I think effective platform engineering approaches will absolutely consider networking as a first-class concern, not as a bolt-on or afterthought, but something that they're planning for upfront. That's a little bit difficult to do today because if you look across the industry, there's not a lot of great tooling that can serve all of your applications regardless of where they live. You want to have one definition of your network security policy, for instance. Defining that twice is dangerous, both in terms of accidentally denying traffic that you meant to allow, but more importantly, not understanding the holes in each layer that potentially line up and create vulnerabilities for you. So you want one definition of that, but the tooling is sort of lagging behind in that process today. So platform engineers actually, in my experience, have to spend a lot of time thinking very carefully about how they design the network.
Based on what you said, it sounds like there'll be this small, super capable group, agile group, platform engineers that become the glue between your traditional networking crowd and traditional security crowd, and then your DevOps or your container gurus that are focused on just deploying the code into the container and scaling the application through Kubernetes. And so they'll be the meeting of the minds, as it were.
Yeah.
Do you feel that that will work in an enterprise scenario? Because in an enterprise, it seems like today, typically, you have all the networking people in one room and all of the Kubernetes people in another room, and they're kind of working in parallel or sometimes against each other. So how would a platform engineering team help close that divide?
So no one's ever asked me to design a platform engineering team or to run an org
Right.
like that, and they probably shouldn't. I'm an individual contributor, not a manager, but I think if I were to design such an org, I would either place those teams very close to one another or
Yeah.
actually on the same team. The network and the orchestration tools that you use need to fit hand and glove with each other. And so if those teams, Conway's law says that the further apart you are in an org structure, the less compatible your technology will be
Yes.
between the two teams. And so having close proximity between those two groups, I think, would be very advantageous.
Do you see a lot of enterprises deploying two separate teams for networking, having a Kubernetes shop to do Kubernetes stack stuff, and then having a traditional IT shop? And if so, what are some of the problems with this approach?
So that does not make up the majority of the platform engineering teams that I've looked at. I think most enterprises can't afford two teams,
Yeah.
and they know that. However, I have seen that played out in a few places. And in my experience, it can result in some tension. And the tension reminds me of a really nerdy sort of example. I hope it's okay to get extremely nerdy on your podcast.
Always.
My kids are really big fans of cosmology and astrophysics. They're in middle school. They don't really wrap their heads around all the math, but we found a few courses that really talk about. Actually, there's one at the bachelor's degree course on astrophysics for English majors. So it's explained in simple terms. It doesn't rely heavily on math, and yet it really does go through the major developments in cosmology throughout the 20th century. And of course, the 20th century was defined by a similar tension between two groups, right? We had the theory of general relativity, which deals with the universe on a very large scale and sort of predicts the shape of time-space as a single entity that is curved in on itself in this really interesting way. and is continuous. Curves, of course, are continuous, not made of individual pieces or straight lines. And all of the tests we can do show that the predictions of general relativity come true. But there was another set of sort of theories that deal with the universe on the absolute smallest scale. Of course, that's quantum theory. And in it, we find that the universe is not continuous, that everything in the universe, whether we're talking about space-time or matter energy, everything is packetized into discrete grains or quanta. So they make completely incompatible analyses of what the universe is fundamentally like. And for the most part, that's been okay because quantum theory deals with the small stuff, relativity deals with the large stuff. They can sort of stay in their corners. But there's one place where they're both relevant, and that's in a black hole. We don't know what goes on inside of a black hole, right? This is a part of space where gravity is so strong that even light can't escape. But general relativity predicts that these curves, you almost picture two circles that come together at one point precisely. It predicts that at the center of the black hole is a singularity, an infinitesimally small point where matter is condensed. Of course, if you've been paying attention to quantum physics, we've said an infinitesimally small point is not a thing. There is nothing below the Planck length. That is the resolution of our universe, so to speak. So suddenly, general relativity and quantum theory come together in one place. And so our hope for rationalizing or reconciling these two models in physics, I say our like I'm going to have something to do with it. I'm going to have nothing to do with it. I will be a fan standing on the sidelines waving a flag and barely able to understand things that are happening on the field. But
yeah,
the general hope is that at black holes, we might be able to begin to bring these two theories together into a standard model of how the universe works. That was a really long and nerdy analogy, but I think the same thing is happening in Kubernetes. We have two very contradictory ways of thinking of the network. In Kubernetes, you're thinking almost exclusively about layer 4, TCP, TLS, and layer 7, HTTP, or potentially some proprietary database protocols you may be using at layer 7, gRPC built on HTTP. That's a very interesting way of thinking about your network. There's a lot of very useful abstractions there. It's the way a lot of developers think about their network, incidentally. But then there's, within the traditional networking world of VPCs and subnets, we're at layer 3. We're thinking about IP addresses, subnets, sort of a hierarchical structure of our network where the location on the network means everything as far as what privileges you have. Within the Kubernetes model, your location on the network means nothing. It's your layer 4 identity that gives you access to resources. I'm blending right now Kubernetes and service mesh, but they tend to be used hand in hand.
Yeah.
So we've got these two ways of thinking about the network that are very hard to rationalize, very hard to reconcile with one another. They're not quite as incompatible as general relativity and quantum theory, but sometimes it feels like it. And you can feel that tension between network operators of these two layers and how they think about their networks. And it's not just networking. You think about everything sort of differently between Kubernetes and traditional workloads. I think the network is like a black hole in that it's where these two things have to come together. If you're just running an app, you can think about containers, or you can think about VMs. You probably don't need to think about both because you're running one app. It probably runs on one or the other. But if you're running the network, you've got to handle both of them. They've both got to be able to communicate, or you've got to be able to control the communication of each and secure it against intrusion, against lateral movement. So suddenly we have to rationalize these two different schools of thought. We need a standard model for thinking about networking that works just as well for the 85% of application workloads that are still in VMs today. Need to have just as much right and privilege on the network, just as much fluidity in how we're able to define their network policies as containers. I think that's where we're going as an industry. It's going to take a little while to get there.
Yeah, so the black hole analogy is great. Didn't you do a piece on that?
Yeah, that's not quite out yet, but we can keep your eye out on social media for that over the next couple of weeks.
There you go. All right, so folks, keep a lookout for Mitch's piece on similarities between quantum physics and Kubernetes networking from a functional model. That's going to be an awesome read. But I think the idea of a black hole is very appropriate because for a lot of traditional networking types, what goes on inside of a Kubernetes or container, well, yeah, for a lot of traditional networking types, what goes on inside of a cluster, a Kubernetes cluster, is just dark, right? It's packets past the event horizon. They go in, just really no visibility in terms of what's happening in there. But from pod to pod, container to container, the only time that they really get an idea about what's happening is when traffic is moving between clusters.
Yes.
but then IP address is disingenuous, right? They don't know what workload or what application environment that IP address may necessarily be attached to, because the cluster networking stack is natting all this stuff, right?
Exactly.
So it's really hard to take that IP-based, position-based approach to containers networking. And this has been a huge challenge for cloud networking architects and traditional networking folks, even that might be running containers on-prem in a private cloud. So you talked about this shared model of networking that can reconcile that. What would that look like?
That would look like a single source of truth for what can happen on your network. That's in terms of security policy. And of course, security policy is always anchored in identity. So a single way of referring to the identity of an entity on your network. Right now, it has to be hybrid. You can say the identity service X, which runs in Kubernetes and gets this fancy, maybe spiffy identity in order to represent it, can talk to IP address 10.178.3. There's a mismatch there. And putting those things together is fairly challenging. You typically have tools that think either in terms of IP addresses or in terms of on-the-wire identity. We need to iron out that scheme into a single source of truth. And I think identity is probably where things are leaning. The nice thing about identity is when you restructure your network, if all of your security policy or your concept of identity was related to the location on the network, you now have to rework all your policy. Your firewall rules need to be rewritten from scratch because you've restructured your network. Maybe you didn't save enough IP addresses in one subnet, and now you've got to reallocate your address management sort of stack. That's really challenging. If, on the other hand, all of those machines have a way of accessing a secure cryptographic identity, and our policy can be written against that identity, which is effectively what happens in a service mesh, but only inside of Kubernetes. If every machine suddenly could do that, then you can say, we can move this machine around pretty flexibly because very little or maybe even none of our policy is relative to your location on the network. It's relative to what keys you hold as someone accessing the network, what badge you show. To put it in terms of like employees at a large corporation, you've always got a badge, and that badge determines what buildings you can get into and what buildings you can't get into, rather than saying, well, everyone in this hallway has access to these 7 rooms. So that's sort of how things, I think, are shaping up and changing. It's a hard problem, to be sure, and there's still a long ways to go. The thing is, platform engineers can't wait for this problem to be solved.
Right.
And I don't mean can't wait like they're excited. I mean they're not capable of waiting for this problem to be solved. If they can't find it in the marketplace today, they have to build it for themselves. And so that's what we're seeing, a lot of tension around networking and platform engineering, a lot of heavy lifting going on. I think we can do better as an industry.
So, I know that we can't go at great depth here, but how can Aviatrix help in this kind of paradigm? Because you mentioned what we need is like a service mesh-like network that brokers and understands identity. And then the location of an object from its networking perspective can be obfuscated and managed in a centralized way, and thus becomes kind of arbitrary to the end user. That is obviously what Aviatrix is doing with the distributed cloud firewall product at an IaaS and PaaS kind of level. There's an obvious potential for success here. Can you talk a little bit about that?
Well, actually, I want to take a step back first before we have that conversation, because this is not a new story for Aviatrix. We talked about the cloud migration and kind of how that went down. And if you remember 12, 15 years ago, the first cloud migration you did, if it was early on, you were probably doing it as an engineer, not as a network operations guy. Before long, your network operations team or other IT team would come to you and say, hey, what is this thing? All of a sudden, I see it connecting to our on-prem data center. What's there? I can't tell what any of this traffic is. I can't tell what any of our spend is. It's just a black hole of budget, a black hole of traffic, a black hole of infrastructure. How do we wrap our heads around this? Well, that's because the developer persona typically doesn't ask permission, right? We create a lot of problems for IT. We'll just go and build something, and if it works, that's great, and we'll wait a few years for IT to catch up. And that creates a little bit of an antagonistic relationship, but that black hole story is similar, right? Today, what's happening is a developer at a large enterprise is going to say, hey, this problem's easier to solve in Kubernetes. Let's go ahead and spin a cluster up. start solving problems, become important to the business. And before long, IT's looking at it saying, look, they just asked to provision a /14 network. Everything else is a /24. They just provisioned 1/64th of the privately addressable space in all of IPv4 for one cluster. We'd better get our heads around what's going on there. And they're
Wow.
struggling. So just the way that we helped IT teams and network operation teams with that cloud migration wrap their head around it, we're going to help them with the Kubernetes migration as well. This is the same song, just the second verse. We already know how to sing it. So the way to sing it, first thing, expertise. Aviatrix has done an amazing job of establishing ourselves as world-class cloud networking experts. If you're looking for help, if you're facing some really tough problems on your network, our solutions engineers and architects are top-notch and can help you make sense of what's going on today with your cloud migration and your multi-cloud presence, your perhaps edge presence with Equinix, but tomorrow, and I do mean very, very near future here, with Kubernetes as well. So that expertise is going to be extraordinarily important to our users. But to go along with that expertise, we do need functionality. I can't quite blow the lid on this yet, but pay attention to our website and swing by our booth at KubeCon on March 19th through the 22nd. We're going to have some very exciting announcements to share with everyone.
Oh, that's great. So you're going to go, you'll be there, right? You'll be at KubeCon.
Yes. Yes, we will be in Paris together. It will be Aviatrix's first time having a booth at KubeCon. I am extraordinarily excited. For 2 years now, every KubeCon, I get the question like, hey, I'm really interested in what you guys are doing. Where can I go to learn about your stuff? I'm like, maybe the website. Now we actually have full-fledged presence at KubeCon with some of our best solutions engineers for you to talk with about how Aviatrix can help with your Kubernetes adoption. But I don't want to blow the lid on it any more than that.
Right. Okay. So folks, if you want the skinny on what's really happening with Aviatrix and Kubernetes, stay tuned for some very exciting and interesting press releases. But also, if you're in Paris for KubeCon, make sure to stop by the booth, say hi to Mitch and his team. And at that point, they'll have some great news for you. So last question. This is a question I wanted to ask earlier in the interview, but I just didn't get around to it. You had mentioned that Kubernetes and containers have, you said, between 5 and 15% adoption. Is that correct?
Yeah.
To what degree do you think difficulty with networking and infrastructure is causing that number to stay small?
I think it's a substantial degree. If you look back at the market forecasts maybe 4 years ago, when I was at Google working on service mesh, they told us that by 2025, service mesh would be a $5 billion market. Not millions, but billions, right? And I don't know what the market looks like today. There's not been republished research, but by and large, that forecast has not really come to fruition. Organizations are not buying service mesh to the degree which the analysts thought they would. And I think it's because service mesh is a panacea of networking. It really is amazing. The features, I mean, I can't say anything bad about service mesh, right? I sit on the Istio Technical Oversight Committee and Steering Committee. So Istio is a wonderful platform. I love working with you all in the Istio community, and I'm thankful for you. But what we've not done a good job of in Istio or other projects is serving VM customers well. VMs are possible to join to service meshes, but they're very high friction and high cost. And I think until you can serve the 85% of enterprise apps that are still running on VMs with the network just as well as you can serve the 15% that have made it to Kubernetes, those sales are going to stay extraordinarily suppressed. To really succeed, you've got to be able to work well in both worlds.
I agree. I completely agree. So Mitch, thank you. That was an awesome answer. And with that, we're coming up on time. So I just want to thank you for coming on the show and really giving us a fantastic update on Kubernetes, what's happening in the industry, and letting us know about the exciting new development of platform engineering. And I really look forward to the upcoming news about Aviatrix and Kubernetes. So thanks again. It was great.
Thanks, Woody. It's going to be a really exciting month.
Yeah, you bet. Take care.
You too.